Today we'll be talking about adding mixed numbers. So there's clear steps we take, and I promise you, if you will commit these steps to your memory, it will make this process a whole lot easier. So make sure you make an effort to put these steps in your mind. So first, we will line up the mixed numbers horizontally. So that's the first thing we're going to do, and often they are written that way already, from left to right. The next step is to find the least common denominator of the mixed numbers. Occasionally they'll have the same denominator. You won't have to do this, but most of the time they'll have different denominators. And just a reminder, the denominator is the number that's on the bottom of the fraction. Next is to make equivalent fractions using the least common denominator. That's where you have to multiply the top and bottom of a fraction, or both fractions, by a certain number so that their denominators will be the same. So tell you what, I want to go ahead and start the first example as we go through these steps, because I think instead of just listing all the blanks, it'd be better if we actually start doing one to see how this works. So on number one, they're already listed horizontally. Again, that's from left to right. That's good. So then we want to find the least common denominator. So as I look right now, I have a 6 and a 4. I want to think of the smallest number that both 6 and 4 go into evenly. Okay, that would be 12. So to turn a 6 into a 12, I have to multiply it by 2, and whatever you do at the bottom, you have to do the same thing at the top. So I have 4, and now it's 5 times 2 is 10, 6 times 2 is 12. And then here, to get to 4 changed to a 12, we multiply by 3. So multiply the top and bottom by 3. 3 times 3 is 9. 4 times 3 is 12. Oh, sorry, I forgot to write this whole number 3 right here. Not too concerned with the fractions. So we have 4 and 10 twelfths plus 3 and 9 twelfths. So now they have equivalent fractions, because 10 twelfths is equal to 5 sixths, and 9 twelfths is equal to 3 fourths, but the benefit is we can now combine those two once we're ready to add, because they have the same denominator. So we've covered steps 1 through 3. We wrote them horizontally. We found the least common denominator was 12, and we multiplied the fractions by numbers that would make it so that they do have the same denominator. Next, step 4 is to add the whole numbers. So let's go down and do that. So they're just saying do 4 plus 3. Well, that's 7. Then we add the numerators, but we keep the denominators the same. So when you're adding and subtracting, this is important to remember. When you're adding and subtracting, the denominators do not change. You can change them to make them equivalent like we did before, but when we're adding and subtracting, the denominators do not change. That's why we add the numerators. 10 plus 9 is 19, but we keep the denominators, 12, the same. So we have 7 and 19 twelfths. However, if the fraction is improper, which this one is, write it as a mixed number and add it. So here's what they mean. We're not allowed to leave the answer this way because 19 twelfths is an improper fraction. So if you think about it, we say 7 and 19 twelfths, which is really the same as saying 7 plus 19 twelfths. We don't have to write that plus, but for a reason you'll see in just a second, it's helpful to write it when we have an improper fraction. So we need to change this improper fraction to a mixed number. To do that, we say, how many times does 12 go into 19? Well, that would be 1 time. But 12 would go into 19, and then there'd be 7 left over, because 7 plus 12 is 19. So this 19 over 12 is the same as 1 and 7/12. So we can combine these now. 7 plus 1 is 8, and we have the fraction 7/12. So I know I'm not able on my screen to show the steps at the same time I'm doing the problems, but make sure you are looking at the steps as we go through them. So I'm going to try to talk through them as we go through each of these. Sorry about my typo here on number 2. This should be a plus. But we'll follow the steps. Step 1, line up the mixed numbers horizontally. Check. Step 2, find the least common denominator. So we got to think, what's the smallest number that can go into, that both 9 and 12 can go into? Well, that would be 36. So I multiply the top and bottom by 4 here, because 4 times 9 is 36. So I get 7 and 16 over 36, plus, I need to multiply 12 by 3, so I multiply the top and bottom by 3, and we get 21 over 36. There doesn't need to be a dot there, I'm not sure why I put one. Okay, so we have made equivalent fractions, that's step 3. So now that we can combine those fractions, we add the whole numbers. 7 plus 13 is 20. And we add the numerators. 16 and 21 is 37. We keep the denominators the same, 36. We have our answer. But similar to the last problem, we ended up with an improper fraction. So I need to write that improper fraction as a mixed number. 36 goes into 7. Actually, let me pause a second. I want to make sure you understand what improper fraction means. You may know it very well, but just in case. When the numerator, the top number, is bigger than the denominator, that's when you have an improper fraction. So you say 36 can go into 37 one time, and there would be 1 left over. So 37 over 36 is the same as 1 and 1 over 36. Then we can say 20 plus 1 is 21, and 1/36. Okay, number 3, same process. Write it horizontally. Check. Find a common denominator. For 4 and 5, 20 is the smallest number that would go into both. So I need to multiply this one by 5 over 5, because 4 times 5 is 20. So 1 times 5 is 5, 4 times 5 is 20. Need to multiply this one top and bottom by 4. 3 times 4 is 12, 5 times 4 is 20. So I've done the first 3 steps. I made sure it was horizontal. I figured out the least common denominator was 20, and then I made the fractions equivalent so they had the same denominator. And just to be clear, I'm not making this fraction equivalent to this fraction. We're pointing out that 1/4 and 5/20 are the same, 3/5 and 12/20 are the same. They're equivalent to each other. Now we add the whole numbers. 3 and 2 is 5. We add the numerators. 5 and 12 is 17. We keep the denominators the same, which is 20. And this did not give us an improper fraction, so we are done right there. We did not have to do the last step on that one because we didn't end up with an improper fraction. Okay, number 4. Step 1 is already done. It's written horizontally. Step 2, we figure out the least common denominator. For 3 and 8, 24 will be the least common denominator. So I'll multiply the top and the bottom of this one by 8, because 3 times 8 is 24. So 1 times 8 is 8, 3 times 8 is 24. Multiply this one top and bottom by 3, because 8 times 3 is 24. 1 times 3 is 3. 8 times 3 is 24. Then we add the whole numbers. 2 plus 3 is 5. We add the numerators. 8 plus 3 is 11. And we keep the denominator the same. And this is not an improper fraction, so we can go ahead and say we are done. Okay, now we're on the back of the page, number 5. I want to follow the same process. Step 1, make sure they are listed horizontally, which it is. Step 2, figure out the least common denominator. For this one, that'd be 18. That's the lowest number both these will go into. So to get 9 to turn to 18, we multiply by 2. And whatever we do to the bottom, have to the top. 2 times 2 is 4. 9 times 2 is 18. And we have to multiply 6 by 3 to get 18. 5 times 3 is 15. 6 times 3 is 18. So we've done steps 1 through 3. Now we add the whole numbers. And we add the numerators, 4 plus 15. And we keep the denominators the same. We again have an improper fraction, so we need to convert that to a mixed number. So the 5 stays the same, but 18 goes into 19 one time, and that leaves 1 left over. So we combine the 5 and the 1 and get 6 and 1/18. Okay, number 6 is a little bit different from the others, but in its a way that makes it a little bit easier, because the smallest number that both 4 and 8 will go into is 8. So we don't have to change this one at all. It's already the denominator we want it to be. We only have to change this one by multiplying the top and bottom by 2. Because once we do that, 2 times 3 is 6, 4 times 2 is 8. Then we have common denominators, and we can combine them. So that will happen occasionally. Sometimes they may give you ones where it's already the same denominator, and sometimes, like this one, only one denominator has a change to make them match. 6 plus 3 is 9. 6 plus 5 is 11, and we leave the denominators the same. We yet again have improper fraction. So 8 will go into 11 one time with a remainder of 3. So we end up with 10 and 3/8. Okay, the 7 is the last one I'm going to do for this video. 8 and 9 are really the same thing, just doing 3 in a row instead of 2 in a row, but the process is the same, so I just want to focus on making sure you understand the process. Those are the steps, what we've done on all of them. So make sure it's horizontally listed, check. Common denominator between 5 and 2, that would be 10. So to change a 5 to a 10, we'd multiply by 2. 11 times 2 is 22. 5 times 2 is 10. To make 5 into 10, 2 into 10, we'd multiply by 5. 5 times 1, 2 times 5. I'm going to pause right here because some of you may be wondering, now wait a minute, why did they write this as an improper fraction instead of a mixed number? I don't know why the math people chose to do that. And if you want to, at the very beginning of the problem, change this to a mixed number, there's nothing wrong with doing that first. But since we also commonly have to worry about the mixed number issue at the end of the problem, I just chose to wait till the end to fix it. But you can fix it on the front end if you want to, and that's completely fine. So I have no whole number out here, it's understood 0. So 0 plus 1 is 1. 22 plus 5 is 27. And we keep the denominator the same. So at the moment we have 1 and 27/10. Well, 10 goes, this is improper, so we got to fix it. 10 goes into 27 2 times. And that leaves a remainder of 7 over 10. So 1 plus 2 is 3 and 7/10. Now, like I said, you could fix this up here and rewrite it as 2 and 1/5. And following the same method we did all through the process, you'd still get this answer at the end. So if you'd rather fix the improper fraction at the beginning, feel free to do so.